Good coffee morning, neighbors. I was a little bit pissed off in yesterday's last video. It's not really pissed off, it's frustrated. To listen to some of this politics over a lifetime with just a different perspective on the world around us than a lot of people have. For better or worse, you judge. People like to do that. So I've been contemplating Mr. Einstein and his theory of relativity, capital R. The importance of that equation in everyday life is huge. I can extend conversationally out into the theoretical physics and the accuracy of high purity elemental analysis for computer chip manufacturers. But so these things matter a lot more to some people and places than others. Einstein did not invent the theory. He was the first to publish it. But when you go back in written history, not written history with a sequence of events leading up, we can follow this. We can trace this back in our written and oral traditions through the people. We know the discussions at that time in very close circles. This is religion level stuff. These folks like to talk among themselves. But this E equals mc squared. The format for that equation, A equals B times c squared, is a generic formula. Turns into E equals m times c squared as an energy equation. Another energy equation is P equals R times I squared. It's a power equation. That's resistance times the current squared to give you the power in a circuit. And then we could go on and describe that power in decibels or in watts or in joules or in coulombs, depending on which lab you're in and who your peers are. E equals mc squared. Now, what that describes is general relativity, right? We also know that the equation is weak. When we get to subatomic particle physics, there's more to it. It's not that the equation doesn't work, the accuracy of it gets worse and worse as we get into subatomic levels, because there's particle physics that we just don't understand enough of yet, especially in general conversation. So that E equals mc squared is pretty big stuff in the maths world, in the science world, in the physics world, in the chemistry world. These equations, the format of that equation follows all over the place. But what it's describing is the idea of relativity. That E is related to the M and the C. Okay, M is mass, so you have to pick something to figure out what its mass is, and C is a constant squared. In this iteration of the formula, C is the speed of light. So this is pure energy equation, yet it applies. That theory of relativity applies to so much. Those other codependent variables. Mass, C is the speed of light. But when I put that into P equals R, resistance times current squared, I've got different variables there. But they're relative. Kind of one can't, if one doesn't exist, the others can't exist. Yet they have. So it gets very complicated quickly, but that relativity thing still comes through there. That complicated equation, that multivariant sum, Lots of ways to phrase this, but just the general idea of relativity. And then you take that back in time over billions of years. And those formulas, those equations still worked back. They just didn't exist. But we can use them to look back. Too long on relativity. But it's an important word, an important concept in life. You know, this, what Kevin Bacon, 7 degrees of separation. There is some relativity in that conversation. The amount of CO2 in the air is certainly related to something. The amount of methane in the air is related. The amount of ozone in the air is, we proved the ozone thing long ago, so confidence in that one, that we understand a good bit of what we're talking about. Understanding what it is.